Okay, so I know many of you guys had trouble with the homework, so I wanted to make sure that you understand these concepts. So I'm going to go ahead and do the key on this video, so that way you can, if you have trouble on number 4, just fast forward to number 4 and do that problem instead of watching this entire video. But I wanted to give you some help on some of these. So it says grain is stored in a tank made from a cylinder. So this portion is a cylinder. And a cone. So this portion down here is a cone. With the vertex pointing down, a picture is shown. The cone part of the tank has a height of 5 feet and a radius of 4 feet. Okay, suppose the tank is nearly empty and the grain fills the entire cone portion but not the cylinder. When the tank is open, grain flows out at 0.5 cubic feet per second. Answer the following questions using the volume of the cone, which is V equals 1/3 pi r squared h. So how long does it take for the tank to completely empty? So basically we need to come up with a volume. So our volume is 1/3 pi, r is 4, so 4 squared times 5. And we can find that. So we get 80 over 3 times pi, which is approximately 83.776. So if we want to know how long it takes to empty, this is our value in cubic feet this is the value in cubic feet. And we know that we want cubic feet per second. So if you think of a normal conversion, maybe that will make more sense. So if we want in seconds, we're going to start out with our 83.776 cubic feet. And we're going to say for every 0.5 cubic feet, it takes 1 second. So you can do it like that, like a conversion, and you would see that your feet cubed cancel. And then we get just 83 divided by 0.5, which is the same as multiplying by 2. So we get 167.552 seconds. Okay, or you could think about it logically, and you could say, well, 1 full cubic foot is flowing out at a rate of 2 seconds, right? So for every 2 seconds, 1 full cubic foot is gone, so you just multiply your answer by 2. Part B says write a proportion to relate the radius and the height of the grain at any point. So that's using the fact that your radius is 4 and your height is 5 for the whole cylinder. Now, as water goes down, you're still in that same ratio. Let me kind of draw it separately. So we have 4 and we have 5, and then we have R and we have H. So that's what we're going to use. So we're going to say 4 over 5 is equal to R over H, and that would be enough. And you could have that lots of different forms. You could say 4 over R equals 5 over H, and so on. So it says, what will the height of the grain be after 4 minutes, or after 2 minutes? So we know that we're losing, let's see, 0.5 cubic feet every single second. So after 2 minutes, right, that's the same as 120 seconds. So in those 120 seconds, we will have lost, so 0.5 for every second, so 60 cubic feet. So that means our volume has to be 60 cubic feet. So we're going to have 60 equals 1/3 pi r squared h. And in order to do this, we're talking about the rate of change. I think I said water earlier, but the grain. So our grain is coming down at a certain rate. So we don't know that specific R and H, but we do know that they're in that same proportion. So if we go back up here and we simplify, we're trying to find the height, so let's solve for R. R is equal to 4/5 H, and we plug that in. So we have 1/3 pi times 4 over 5 H squared times H equals 60. We multiply the 3 on the other side, so we get 180 equals pi times 16 over 25 H squared times H. So I just squared the 4 over 5. And I multiply my 25 over 16 over. So I get 281.25 equals pi times H cubed, divide by pi. So 89.525 equals H cubed. And then on my calculator, I'm going to raise to the 1/3 power. That's the same as taking the cube root. So I get H equals 4.474. Okay, so that's in feet. All right, so it says find the height of the grain when half of the original volume is gone. So if half of the original volume is going to be gone, that means that instead of having our volume of 83.776, we divide it by 2. So I'm going to go ahead and keep it really precise, and I'm going to do 80 over 3 pi again to get that number back on my calculator. All right, and I want half of that, so I'm going to divide by 2. So I get 41.887, or 888 actually. And I want that to equal 1/3 pi r squared h. So again, for r, I'm going to plug in 4/5 h squared times h. And I'm going to solve. So I'm going to multiply by 3. I'm going to divide by pi. I'm going to multiply by 25 over 16. And then I'm going to take the cube root. So just like we did on the last example, and we get h is equal to 3.969. All right. And the last one, so it says, suppose the height of the cylinder is 18 feet if the entire tank is full. So we have a cylinder, and the height is 18 feet, and then we have the cone underneath. How long will it take for the tank to completely empty? So again, that 83.776 is the portion of the cone that's totally full. And we're going to add it to, we used v equals pi r squared. R is 4 still, because it's still just the radius of that cone is the same as the radius of the cylinder. And then h is 18. All right, so when we find that answer, okay, so we have 904 plus the number that we had before. Let me find it. The 83.776 and so on. So you should get 988.554 for how many cubic feet it has. So when it says, well, how long will it take for the tank to completely empty? Again, it's losing 0.5 cubic feet every single second. So every 2 seconds, it's losing the full cubic foot. So you're going to multiply by 2 or divide by 0.05, and you get 1977.109 seconds. Okay, and you could find out what that is in minutes, you know, divide by 60 and so on. But I'm fine if you just keep it in seconds. It's around 32 minutes, I think. All right, so the next one. So 2 and 3 were pretty easy, so hopefully you guys figure these out. So again, if you need to fast forward, you can. But it says the relationship between boiling point of water and height above sea level is linear. So if you have a line and it says height above sea level is x and boiling point of water is y, then I'm going to do a height of 0 and a boiling point of 212. And I have a height of 1100 and a boiling point of 210. And I come up with the slope. So 210 minus 212 over 1100 minus 0. So I get -2 over 1100, which is the same as -1 over 550. And I come up with y equals mx plus b. And in this case, I actually do have b, right? B is the y-intercept, which since it's 0, 212, it needs to go over 0 up to 12, so b is 212. So I have -1 over 550, x plus 212. All right. So it says find the boiling point of water for each of the following cities. So this is the, as you can see, the height, which we said the height was x. So what we're doing is we're plugging in x equals 550. And in this case, the 550s cancel, so I get -1 plus 212, so I get 211 degrees Fahrenheit. But the next one, they do not. So if I do y equals -1 over 550 times 1300 plus 212, for this one, I got 209.636 degrees Fahrenheit. And then same idea for the next one, so you can plug that one in. So I just did second enter so I could get that same equation that I just entered, and I changed the number. So 206.327 degrees Fahrenheit. And then the last one, so I get 199.455 degrees Fahrenheit for that one. All right, so it's the same idea for number 3. Again, so I tell you the average life expectancy is y and the year is x. And x should correspond to 1945. So 1945 is going to be like our x equals 0. So I'm going to have 0, comma 64.9, and I'm going to have how many years after is 1980, so it'd be 35 years after is 76.4. And again, I come up with the equation. So I get m. So I have 76.4 minus 64.9 over 35 minus 0. So I get 0.329. We'll use that. Or you could have gotten the fraction 23 over 70. If it's possible to do the fraction, I usually do. So I get 23 over 70x plus 64.9. And you could find what that is as a fraction as well if you want to. So many of you guys use 1945, which is fine. Like, just be consistent throughout your problem. So if you use 1945, then make sure you use 1980. And then on part B, make sure you use 2000. But in this case, if I have x equals 2000, I know that that is 55 years past 1945, so that's the number that I'm plugging in. So I saw a lot of you guys have answers that were kind of crazy, like 700 years old, right? That's not going to be the life expectancy, so maybe you had a little error like that. All right, so when we do that, we get 82.971, so about 83 years old. All right, so number 4. So this is the one I probably had the most questions about after class. So it says a rectangular box with a square base and no top has a volume of 2,000 cubic inches. If the surface area is 900 square inches, what are the dimensions of the box? So step 1, I said write an equation for the volume of the box using this picture. So a lot of you guys did not look at the picture and look at the variables that I had. So our volume should be s squared times h, length times width times height. Okay, and I saw a lot of people just write length times width times height, right? You use the values from the picture. And we know that the volume has to be 2,000. So step 2 says take this equation and rearrange to solve for h. So we get h equals 2,000 over s squared. Excuse me. All right, step 3 says write an equation for the surface area. So when I talk about the surface area, what I'm saying is, what is the volume of the front piece? Well, the front piece is s by h. And there's 4 of those. So I have the front, I have the right, I have the back, and the left, right? So I have 4 of the s times h's. And I have one box, right, or one square, which is on the bottom, which is s squared. I do not have the top because it had no top. It's open. And I know my surface area should be 900. So I have 900 equals 4sh plus s squared. But the problem is that I have 2 variables. I have s and I have h. So I need to solve for one of those variables, which I've already done. I found that h was 2,000 plus s squared. So what I do is I replace that with 2,000 over s squared. Plus s squared. And now at this point you could graph for y1 and y2 and find the intersection point. Or you can multiply and kind of reduce. So we should get 8,000 over s plus s squared minus 900 equals 0. And we could find the x-intercept. Okay, so if you think about it, your answers for s should be kind of small, right? It's not going to be, like, it's not finding the volume or anything. So it's going to be probably less than 30. So we'll make our window go to 30 for the x values. So I'm going to do 0 to 30. And then my y-min, I'm really just trying to find where it crosses the x-axis since I've solved for 0. So when I hit graph, it's okay if I have my window as like negative 10 to 10 or whatever. And I can see that there are 2 places where it's crossing the x-axis. So I can't see much of my graph, but I can see this and I can see this. And that's what I'm trying to find. So I do second trace, intersect 0, so the second choice, and I get on the left side of it and I get on the right side of it. And there's actually a couple different answers. So left bound and right bound, and then guess. All right, so the first one that I find is 10, so x equals 10. And then when I find the second 0, it's actually another solution for this problem. And I think that's where I confused a couple of you guys, because you're like, wait, can you have more than one answer? And in this case, you can. So as I find this answer, I get 23.723. Okay, both of those will work. So when it says, what are the dimensions of the box, there's 2 answers. So if s is 10, then that means I have 10 inches by 10 inches by, and I plug into this formula, right? So if I do 2,000 divided by 10 squared, 2,000 divided by 100, whenever you divide by things with zeros, you can cross out the zeros, so I get 20. So it's 10 by 10 by 20. Or if I use this 23 number, and I do 2,000 divided by my 23 number squared, I get 23.723 inches by 23.723 inches by, and when I plug it into the 2,000 over the whatever, I get 3.554 inches. And that's the other answer. So there's actually two answers to that. It's a little tricky. All right, so the next one, the patio problem. So it says Mrs. Cox wants to put a patio in her backyard. She has to pay $1,000 for the removal of her cracked patio, and then she needs to pay $13 per square foot. Labor is included for concrete. A sketch of the patio she would like to have is drawn below. It is 40 by 15 for the rectangular part, and then it is a semicircle that is 13 feet in diameter. All right, so we're going to come up with the rectangle area. So that's going to be 40 times 15. So when you do 40 times 15, you get 600. So that's in square feet. And then the semicircle, if you find the area of a semicircle, it's going to be the pi r squared for the circle, so you divide by 2. So in this case, we have pi times 6.5, which is half of 13 squared. Oops. Push the wrong thing. 6.5 squared divided by 2. So I get 21.125 pi, or if I go ahead and multiply the pi in, I have 66.366. Okay, so my total area is going to be 666.366. So I'm going to go ahead and keep that in my calculator. And I know that for every single square foot, it's $13. So my cost is going to be my 666.366 times 13, and then I'm going to say plus 1,000. Maybe I shouldn't do times with an X in there. A little confusing, right? So I'm going to do times 13, like that. All right, so take your answer, multiply by 13, and then remember it cost $1,000 just to remove the old concrete. So my total cost should be $9,662.76. Very expensive, isn't it? Story of my life right now. All right, number 6, we did this in class, so again, if you need to fast forward, you can. But number 6 says you are planning on making an open rectangular box from an 11 by 17 inch piece of cardboard. So we have 17 by 11. And we're going to cut out corners that are X by X. All right, so that means that this inner portion right here is going to be 17 minus 2x, and that is like the flaps that we're folding up, okay? So this portion right here. And this one right here is 11 minus 2x. So when you fold up the box, you get kind of a shallow box, depending on how big x is, I guess, like that. And you have 17 minus 2x, and you have 11 minus 2x, and you end up with x. So its volume is going to be just that, 17 minus 2x times 11 minus 2x times x. So I told you not to overthink it, and you could use the calculator. So we're going to go ahead and put this into the calculator. But I said you did have to show the volume equation, and we did that. We showed the volume equation. So it's okay that it's not like multiplied out or anything like that. It's fine. So the way you have it is totally fine. You can leave it in its factored form. So under our y equals, we're going to put in exactly that equation. So we're going to have parentheses 17 minus 2x 11 minus 2x and then x. Okay, and we're going to go to window. And if you think about it, if you have something that is 11 inches on a side, the most you can cut out from each side is 5.5 inches. If you cut out 5.5 inches, it's actually too big, right? Because you're going to get, like you wouldn't have a box then. You'd have no like thickness to it. But when you talk about the y is the volume. And it's probably going to be pretty big. So I'm going to do 1,000. Whoops, I did 10,000. Okay, so I'm going to hit graph. And when you do that, you see that you do have a maximum that you can find. So we're going to do second trace maximum. So when it says left bound, get on the left of what you're trying to find and kind of exaggerate it if you're not sure. If you're like, it's kind of flat there, then go definitely on the other side. See how I'm starting to go down. All right, and then I can't really tell in the middle, so that's when I guess I'm just going to kind of go in the middle. So I get 2.178, and I get 182.967. So 2.178 and 182.967. Okay, so x and y. Well, what y is just our volume, right? So our x is the amount that we're cutting out. So it says, what are the dimensions of the box with the largest volume you can make this way, and what is its volume? So the cool thing about the calculator is once you go back to the main screen, see that number 2.1778? If you ever need that number, it pulls up that last intersection point or whatever maximum that you just found. So it's there. So if I want to find the dimensions, what I'm going to do is 17 minus 2x, and it puts that answer in for x, and I'm going to do 11 minus 2x as well. So my dimensions are going to be 2.178. Let me write it as an actual dimension. This is my little decimal point. Inches by 12.644 inches by 6.644 inches. And that's our answer. So our volume is in cubic inches. The x is what we're cutting out from each thing. All right, and the very last problem is kind of a trick question. So I want to show you a table to kind of help us out. So sorry I made this one rough. I know fourth period was really confused about this. So hopefully you're watching the video and seeing it. Okay, so I'm going to actually do three things in this table so you can see. So we're going to talk about the price of the item, and we're going to talk about the profit per item, and then we're going to talk about the number sold. Okay, and let's kind of start in the middle of the table. So if we price it at $5, then he's selling, it cost him $1.50. So he's selling it at $5, it costs $1.50. So it's really $3.50 worth of profit. And when that happens, he sells a total of 275 souvenirs, okay, which is pretty good. All right, but it says for every 10-cent price increase, so if I make it $5.10 instead, then he's making more for the profit, $3.60, but he's selling less. And this is true for any profit or any product that you're trying to sell, right? The higher you price it, the less you're going to sell. It's supply and demand, basic economics. So if I add another 10 cents, then this is going to be $3.70, and then I'm going to get $2.25, okay? So as we work out this problem, as I have X number of price increases, I'm going to have 5 plus 10 cents for each one. 5 plus 10x is the price, but the profit is really not that, right? The profit is what we're worried about. The profit is going to be $3.50 plus 0.10x. And the number that we sell is starting at 275, but we're losing 25 for each x. So that is our profit equation. So it's the amount you're making per item times the number sold. So you can do this a couple of different ways. You could go ahead and multiply it out, or you could graph it and find the maximum. So let's say I multiplied it out, because I think a lot of you guys did that in class. So I want to make sure you have the same number. So you're going to have 962.5. You're going to have minus 25 times 350. So minus 87.5x plus 27.5x from the inner, and then minus 2.5x squared. Pause. Sorry, I'm recording. All right, so as you're multiplying it out, so we just FOILed it out. We can write it in descending order. So we have negative 2.5x squared minus 60 and then plus, or 60x plus 962.5. Sorry, I keep coughing. So if we identify A, B, and C, and notice that we have a downwards parabola, we can find its maximum. So A is negative 2.5, B is equal to negative 60, and C is 962.5. So when we do x equals negative b over 2a, we get positive 60 over 2 times negative 2.5. So we get 60 over negative 5, which is negative 12. So the weird thing about this, and the thing that I did on my key, is I had left off the negative, so I got 12. And so I thought this was like totally fine for this problem. And it's not, because x is negative 12. So what this means, I mean, it's okay. It just means that his price is too expensive, and he needs to go back, right, 12 price decreases. So where does that put him? It puts him back $1.20. So if you do 5 minus $1.20, you get the price should be at $3.80. And that means his profit, if you subtract out that $1.50 that it's costing him, it's $2.30. And the number that he sells, if you go back 12 of these 25s, 12 times 25 is 300. So you're going to actually sell even more, 300 more, so you get $5.75. So his price should be $3.80, and his max profit is going to be, if you take your profit for each item, so $2.30 times $5.75, or if you just plug in x equals negative 12 to your equation, you get 1,322.50. So a little bit more than $1,300, and that should be the answer for that one. So sorry that was confusing. Hopefully you guys watched the video and you understand this now. Let me know if you guys have any additional questions too.